ITS 224, Chapter 8. There's only one part to this particular chapter. Now, also, just as a note, don't do projects 8, 13, 14, 15, or 19. Also, with Discovery Exercise 7, log in with your account and run only ifconfig, and then don't do Discovery Exercises 15 through 22. So other than that, do everything else. Alright, so really this chapter talks a lot about understanding Unix and Linux utilities for file processing, system status, networking, those sorts of things. Let's see, there's categories, network tasks, programming tasks, and file processing tasks. And then the first command that we'll use is dd. And this copies the input file and can convert the file's contents to another format. So you can convert to uppercase or lowercase, and we'll do that. So if in this command designates the input file, so if is input. OF is designates the output file. Let's see, BS specifies the block size in bytes. You have IBS, you have OBS, but you have CONV for convert. So CONV can convert the text to uppercase or lowercase or whatever. Now the example that we'll use is take a look at banana, or take a look at cat zoo2. This is what it looks like. Now if we dd if equals zoo2, that's the input file. The output file is going to be zoo2 underscore test, so it's a brand new file. This will actually create that new file. And then convert equals lowercase, so we'll change everything to lowercase. So let's go ahead and do that. So dd if equals input file is zoo2, output file equals, and I'm just going to zoo2 underscore test, I guess, and then conv equals lcase for lowercase. Okay, so it gives us this output, 0 plus 1 records in, 0 plus 1 records out, and how many bytes were copied. So if we cat zoo2 underscore test is changed everything to lowercase. Really quickly, let's change the case to ucase, uppercase. Let's leave the file name the same. We should be able to view that same file. And now it's all uppercase. Okay. Next step, or next piece of this, is looking at the df utility. And this df utility shows hard disk usage. So df. Now, and when we're looking at this, for instance, your device SDA2, that is the SCSI drive, the primary drive, the second partition. So this shows you in blocks how much space is used, how much is available, and the percent usage, and where that particular device is mounted. I think we also have top. Now this shows the processes, and what is the top processes as far as CPU usage is concerned. So if we look at this line, root is taking 2% of the CPU usage, which is typical of a typical operating system. It'll use a little bit of CPU. You can look in Windows at the task manager in Windows and then see the very same kinds of information. Okay, Q, a small q, we'll go ahead and quit out of that. And then we have uptime. This will show us how long this system's been running since the last reboot. So this system has been up for 45 days and 16 hours and 41 minutes. So that's what that tells us with that. Now free shows us how much memory is free, and we can change that using a -m to megabytes. So free, and it really shows us not just the free memory, but it shows us all the memory used. So it shows where are we at? There we are. Total 997 meg. So in this VM, this virtual machine, now remember, we have a server that has, I think, 24 gigs of memory, and this VM is, with this Linux VM, is taking 1 gig of that. So 922 meg is used, and 74 is left free. So it looks like it might be time for another reboot to just kind of clear that up. But that shows you how much free memory is left in megabytes. And Linux has this pretty small footprint, so 74 meg is really a pretty decent amount of memory. Okay, the next piece is running processes. Now this example shows our manual, and then we're looking at the df command within the manual. Okay, so that's what it's showing us. We don't really care what this df is, but the ampersand is actually a command that will make this program run in the background. So we can exit out of this command and get back to the command prompt and be able to do different things. Now, when we run ps, that shows the processes. And when we look at ps, we'll see something like bash and the ps process itself, but we'll also see all those processes that are running in the background. Now, a number of ways to do this, but one way that consistently works, you kill a process by kill -9 means without a doubt kill that process, for lack of a better word. And then what's the PID of that process? In this case, it's 12080 is the process ID of this particular man process. Then we can look at the processes again, and then we can see it's gone. So let's do that. Man, let's clear here, just clear it up. Man, df, and the ampersand is actually what makes it run in the background. Okay, so we're there. Let's quit out of this. If we type in ps, it shows the processes, and we see bash and the ps process that we ran, and that's the process that made this appear. But we also see this process in the background, this man process in the background. So if I want to get rid of it, kill -9, and you notice the PID number. That will always change. So the example shows 12080, but in this case it's 14896. So 14896, enter, type PS again, and we can see that that man process is gone. Okay. The next piece, commands that we won't take a look at, are ispell. The text has you work with some main particular commands. I think those discovery exercises that we aren't going to do and some of the projects we aren't going to do deals with send mail, which is a basic mail program. Now ifconfig, that's pretty important, but what you need to do is make sure that you add sbin/ifconfig as a as a typical user. So //sbin, and it's just the folder, the directory that's in. ifconfig shows you all the information associated with this particular internet, the IP, the TCP IP setup. On Windows machines, the synonymous command, if you will, is ipconfig. On Linux, it's ifconfig. So the Ethernet adapter itself on this box is 10.48.7.2. As a network administrator, you will need to know that. The network mask is, and that's the subnet mask. That's synonymous with the subnet mask. That's 255.255.252.0. You have the hardware address, okay, or the MAC address, and those are the main. Well, actually, this one is right here. That's the hardware address. Okay. And this is the internet IPv6 address. Okay, so this is what in our classes that we're taking a look at Helena College, other than some IPv6 that Emmett will have for you, these are the network numbers that you'll need to know. Okay, and again, this refers to Ethernet 0. Ethernet 0 is that first Ethernet connection or network interface card on that box. So again, that's /sbin/ifconfig. Finally, well, there's two more pieces. Ping, and you may have used ping a little bit. What we're doing with ping is just saying ping is a program, tests up to level 3, or the software address, and it's simply saying, simply asking a device, are you out there? And are you working up to at least level 3, which is your TCP/IP level? So we're just going to ping a particular box. Now, what if I were to ping? A couple of different ways to do this. Excuse me. When you're troubleshooting, you want to always start pinging your own computer first, just to make sure that the IP stack is correctly set up. Then you ping your gateway, then you just ping, from the closest as you go out. Okay, so let's ping 10.48.7.2. You can ping IP names, you can ping IP addresses. And so we're replying there, so that means it's working up to that point. Now, I can also ping IP names, or just computer names, www.umt.edu. Okay, that's the web server over at U of M. Some of these are blocked, and this is the first time I've tried umt.edu. I don't know if we'll get a ping back on this. We do. Okay, so there we go. We have it's replying so that particular machine works, and the connectivity between here and there is okay. We know that. That doesn't mean our applications work correctly, but that means that basic connectivity is there. Finally, as the example shows, ping yahoo.com. So we can ping clear out to Yahoo, for instance, or some of these sites too, like Cisco, because of a denial of service attack that occurred back 4 or 5 years ago, 6 years ago. You can't ping those boxes, and Cisco is one of those examples. But what we see in this case is pinging yahoo.com. The IP address is 98.138.253.109, and there's probably a series of IP addresses out there, and this is probably the only public one. But that's replying, so our connection out there is working correctly. And that's what ping is used for. And then basic troubleshooting. And then traceroute shows us how many hops there are from router to router to router, and how long it takes to actually get there and get a response back. So we'll run that. Let's see, and make sure that you keep this in mind. That part of it's important. So it's /user/sbin, if I remember right, trace route, and where are you going to? www.umt.edu. And this will go out and ask the different routers and really record the route that messages are taking to that web server over at U of M. So the first goes out to 1048.7.252, that's local at Helena College. 1055, I'm not sure if that is local or not. I know at this point when you hit 172, that's hitting U of M over there and hitting one of their routers. And then there's probably a series of routers and boxes that go out to that particular web server. And then the final box it hits is wtswww.ito.umt.edu at this particular internal IP address. The external is something else, but we're all on the internal side of this network, and then it gives us some other information. So that's how traceroute works. If you have, if you're trying to get out to this box but can only get to this point, you have some kind of connectivity problems, and that's what it can tell you is you're trying to find connectivity issues. Finally, I think here we have file processing utilities, a whole summary of those, additional file processing utilities, and again, we've done a lot of this stuff, make directory, paste, and so on. System status utilities, DF displays the amount of free disk space, free, kill, PS, we've looked at those. Network utilities, ifconfig, ping, traceroute. And then communications utilities, we really haven't worked with any of these, and we won't work with any of those. Security utilities, change mode, that's what we've used throughout. You can also change owner, but change mode is what we've worked with throughout. And then programming utilities, we'll use G++. I'll have to check those activities, those projects and discovery exercises. I'm not sure if we do that in Chapter 8. We certainly do in Chapter 9. And then finally, there's some miscellaneous activities here. So that that really concludes all of Chapter 8. Thank you.